This is pre-calc. This is point 3, day 2. So we're going to factor today. We're going to namely factor quadratics. And some of the things that we're not going to cover on here. Number one, we're not going to cover the fact that you should always look for the greatest common factor, number one. And then number two, there's some other things like difference of squares, sum and difference of cubes. There's a whole bunch of different things that you guys should know how to factor. I'm just giving you quadratics because this lesson's all about quadratics right now. So throughout the rest of the year, we may touch upon some of those other things. I'll try to give you guys a little breakout of those factorizations as well. So, if you notice, I have a quadratic up here, I have one here, I have one here, and I have one here, and I have one there, and there, but those last two both have something different than the first four. Different exponents? No. The first four were missing something that the last two had. Let me go through it again. What do you see different? Right. There's a number in front of x squared. And that number in front of x squared is letter a. If you guys remember, it's ax squared plus bx plus c. So, we're going to start with a equaling 1. These are the nice guys. These are the ones where you're like, hey, if I'm asked to factor this, all I need to do is set up my parentheses, put x, and then look at 2, which is c, and find its factors. What are the factors of 2? 1 and 2 is the only pair. So I put a 1, I put a 2, and now I can ask myself, what are the signs? Why are they both pluses? If there's no negative involved, you know it's going to be plus, plus. The other idea is the fact that they have to multiply to get a positive. There are two ways to get a positive through multiplication. Both are positive, or both are negative. But then these numbers have to add up to 3. But it's a positive 3. And so to make that happen, I want to have a positive 1 and a positive 2. Good. That's easy. We like these ones. How do I know if I'm doing it right? How do you check it? FOIL. Use a 4-letter F word. We're going to FOIL this. Now, someone asked me in one of the other classes, do I have to do this every time? No. It's good to spot check. Am I doing things correctly? Most of us want to know if we're doing things correctly. Allie did on her paper, right? So, x times x is x squared. X times 2, 1 times x, and 1 times 2. 2. And then all you have to figure out is, does 2x plus x equal 3x? Yeah. And so therefore we are correct. Not so bad. Try the next one. You guys do this one. Same thing. A is equal to 1, but they're not both positive this time. One's negative, one's positive. So that could, or will, have an effect on what we do. X. Ooh, the factors of 8. I got 1, 8, 2 and 4, and is that it?
Yep.
I have 2 of them to choose from. Maybe I should put commas in there. Which of these pairs will actually be able to give me a 9? The 8 and 1. 1 and 8. It doesn't matter which one goes first. So 1 and 8. They have to multiply to a positive but add up to a negative. So what should the sign on these things be? Both negative. Because negative 1 plus a negative 8 is negative 9. Not too bad. Next. So this one, hey, a is equal to 1. Put parentheses down, x, 16. 1 and 16, 2 and 4 and... Which one of those pairs? Now we got 3 we can choose from. 2 and 8. So I'm going to choose 2 and 8. 2, 8. Oh, but this time they're going to multiply to a negative 16. That means one of them is, and the other one is negative. So which one's the positive, which one's the negative? It does matter. The negative number is going to be the larger one this time because when you put them together, it results in a negative number. I want it to be a negative 6. That means a negative 8 plus a 2 will give me a negative 6. So are there any questions on factoring? You're going to say, I like these things. If I gave you 100 of these, you guys would be able to pump them out in probably about 5 minutes. And then I give you this one. Try this one. A is equal to 1. We're happy. X, 16 again. 1 and 16, 2 and 8, 4 and 4. Which pair gives me 7? Or negative 7? Which one? What do we recognize? You can't. None of those pairs, adding, subtracting, can give me a 7 or a negative 7. So therefore, what do we say? Ooh, I've heard some things I don't like. No, it's not factorable. Don't tell me it's no solution. You can only have a solution if you have an equation. Guys, every single one of these that I've given you so far are not equations. They are expressions. An equation has to have an equal sign. You can't equal something or solve for something if it doesn't stand or equal for something. So therefore, it's not factorable. But do not get mixed up for the fact that just because something's not factorable doesn't mean that you can't solve it still. Factoring is just a nice and easy thing when the answers are nice. Fractions or whole numbers or integers, you say. Okay? It doesn't work for square roots. It doesn't work for a couple other different values. But fractions is something like one of the first go-tos that I would try when solving. Then we move on to this. Let's think about this. Before I just said, hey, what are the factors of C? C is 5, yeah? Oh, 1 and 5. Wait a minute. 1 and 5, did that ever give me a 19? No. Oh. So that must be not factorable then, right? Well, it actually could be factorable because this time A is not equal to 1. So therefore, we have to consider a different method. 20-some years ago, when I was sitting in desks like yours, I had to do it a little bit differently. I had a little guess and check work to do. I learned as, okay, 4, there's 1 and 4, 2 and 2. 5 is 1 and 5. You guys agree the factor pairs of 4 and 5. What I had to do is I actually had to put this together and say, okay, let's try 2W and 2W, 1 and 5. It's a negative 5, but a positive 19. So maybe this one's positive and this one's negative. Because one has to be positive, one has to be negative. The only way I could know if I'm right, I would have to foil. And if you foil this, it's not going to work. So then what I did was I switched the signs. So now this one's the positive and that one's the negative. Does that work? No. Darn. Okay, then I had to switch the 1 and the 5. Well, in this case, because they're both 2W, we still get the same results. That's okay. That's happy. That's a good time. Then I had to go back and say, okay, maybe it's 4W and W. And maybe it's 5 and 1. Maybe it's positive and negative. Oh, that didn't work? Now I have to cross this out, make this a 5, a 1, this a 5. Does that work? And if those things don't work, I've got to switch the signs. On this particular problem, could have 6 different combinations. I may not get it until the 6th combination. I would have to keep on guessing, checking. What happens if this first number would have been like something like 48? How many factor pairs are there for 48? How about this last number being a 36? So all of a sudden now, I've got like 40 to 50 combinations to put together. And by golly, what is your teacher going to do? Give you a non-factorable one like that. I would have to sit there and check through all 50 combinations before I was allowed to, and I have to show my work for that because you can't just say, not factorable, and take a guess. You had to check them all before you could say it, and you had to show it. Nobody wants to do that. Okay? So, if you remember back from Algebra 1, if you took it here, we taught you a different way. And that other way kind of goes back to using different parts. So instead of just looking at the factors of 5, I am now going to do a times C. 4 times 5, which is 20. What are the factors of 20? 1 and 20, 2 and 10, 5 and 4, or 4 and 5. Any of those pairs give you a 19. 1 and 20. So guess what? You guys be okay with opening your wallet, taking out a dollar bill, giving it to me, and I give you 4 quarters, and you put it back in your wallet, and you close it up? Would you guys still say, I still have the same amount of money? They are equal. That's what I'm going to do here. I am going to take 19W out, and I am going to exchange it for a 1 and a 20. But that 1 and that 20 is going to be in a combination that still equates to 19W. So, what do I mean by that? I still get 4W squared. I'm going to add 20W, but if I add 20W to get 19, I have to subtract a W. Would you guys say that it's the exact same expression? I just took 19 and wrote it a different way. And now I have 4 terms. And when you have 4 terms, you factor by grouping. And so the factor by grouping, I put parentheses around the first 2, and I put parentheses around the last 2. And when you do this, or at least when I do this, I will include the sign in the second group. I do this because I'm going to ask myself, am I taking a positive number out or something out, or a negative of something out? So be very careful on what you do. And now I'm just going to factor each group separately. What can I take out of that first group? I can take a 4W out. And if I take a 4W out, what's left? W plus 5. If I take out, well, what can I take out of the second group then? To make it so it still has a W plus 5 left over. A negative 1. So I'm actually writing negative 1. What's left over? W plus 5. Do you notice that I now have both a W plus 5? And now can I take that out? Factor that out? If I take that away, I'm left with 4W minus 1. And now you're done. If you're unsure, FOIL it. You'll find out you're right. Try this one on your own. First step, since A is not 1, what do? 4 times 5 is 20. 20 or negative 20. I put the sign in after. It doesn't really matter much. 1, 20, 2, 10, and 4, 5. Which one of those pairs will give me a negative 1? And so how would I make a negative 1? So negative 5 and a positive 4R, right? Now, guess what? It does not matter which one goes first. But look at our numbers up top. It's a 4R squared and then a minus 5. So if I'm going to factor things out, wouldn't it make sense to put the 4's kind of together and the 5's kind of together? At least in my mind, at least it makes it feel like I actually can take something out of that group. So 4R squared, and that would be what? Plus 4R minus 5R minus 5. Factor by grouping. What can I take out of that first group? 4R. What's left? Can I take out of the second group? And left with R plus 1. So I get R plus 1 taken out of both. Squish the outsides together. And you now just factor that. Guys, it does not matter if I put the 4R minus 5 first and then R plus 1. Because 2 times 3 is 3 times 2. It doesn't matter. They're multiplied. Order doesn't matter. That's it, guys. That's how you factor quadratics. Now again, look for common terms. If there's a 5 in everything, factor out a 5. If there's an x in everything, take out an x. Factor out that x before you dive in. Make your life easier. Smaller numbers, smaller exponents, all of that. You're going to see that in your homework. Now, the one thing I didn't talk about, because this whole section was supposed to be on, bless you, solving quadratics. That means that our problems originally should have said equals 0. So that means if that's the case, everything is set equal to 0 all the way down to our factored form. If two numbers are multiplied together that equals 0, that means what about your numbers? One or both of them has to be 0. So, what does it mean? It means R plus 1 equals 0 or 4R minus 5 equals 0. And you solve them individually. Guys, we're in precalc now. I should be able to look at this problem and say, I know the answer to that. R is equal to negative 1. Because I just subtract 1 from both sides. This one, we still could get caught up on, but we should be getting there. What's the solution to this one? 5 over 4, or 1.25. Going to the next question before this. Hey, that means this was supposed to be set equal to 0. And if that's the case, the first one is equal to negative 5. The next one? 1/4. Next one's, oh wait, not factorable, so we don't have to worry about it. Next one, answers? Negative 2 and 8. Next one. 1 and 8. Next one. Negative 1 and negative 2, because it's here. We just checked it by foiling it back out. That's today's lesson. So your homework for today is going to be the worksheet factoring quads. First page, odds set equal to 0, solve, do all problems. So you have to do all the problems, but only on the first page, I want you to set the odd problems equal to 0 and actually solve them, just like we did all the way to the point where you say x equals 5 and x equals -7. Have a great day.